Hey everybody, this is Mr. Munson and we are in Unit 7. And so today we're basically finalizing this unit with concept 7.4, real world right triangle problems. So basically I'm going to throw problems at you that have like lighthouses at it and different things that are real world objects. And you have to figure out what we're looking for and decide, is this a trig function kind of problem, or is it a special triangles problem, or maybe it's just a simple Pythagorean theorem problem. Let's get started. Okay, let's first of all review some vocabulary words you should have on your sheet already. If a gentleman is, or somebody sitting up in this lighthouse and he looks out and looks down at the boat, he forms an angle. That angle is called an angle of depression. But if we're looking at the boat and the boat looks horizontally and then up at the light keeper, he forms an angle of elevation. Okay, so we have these two angles in this problem, angle of depression and angle of elevation. Very commonly, students will accidentally put the angle of depression on the inside of the triangle when it really is outside the triangle. Now, I want you to put me on pause and see if you can figure out how to find out what this angle is on the inside of that triangle. Now, if you think about it, this is a right angle up here with this angle of depression happening right about here. So how would I find this angle? I'd simply subtract it from 90. Okay, so once I find that, I can stick it back into my triangle, and that's that angle there. So now remember, we want to be able to look and find different things about these kind of figures, and we're going to be needing to understand our vocabulary words of angle of depression, angle of elevation. Okay, suppose you walk into this problem and I tell you, hey, here's a lighthouse and everything like that, and the angle of depression is 27. You would want to draw this dotted line, just like it is in the picture if it's not drawn already, and you'd put that 27 outside the triangle at the top there. And then we would want to go and find this angle that's on the inside of the triangle. Now once we have that, we have enough information to find how far is the boat away from the lighthouse. The lighthouse, by the way, is 150 feet tall. Okay, so what I want you to do is just kind of think for a second which trig function relates this angle, this side, and this side together to form an equation. Put me on pause and write your equation. Okay, so I recognize that as a tangent. I'm going to go ahead and write my equation with no numbers in there to help me remember it. Then I write the equation, putting the numbers in the proper place. I'm just going to move it over here to the right so I can work on it. Okay, so let's put this over 1 and cross multiply. All right, that was easy enough. And now it's time for my calculator. All right, let's check the mode key, make sure I'm in degrees, and I am. Clear out of that. And so now I'm just going to type in the information. Whoops. All right, very good. I can close my parentheses if I want, and I hit equal, and I get the distance is equal to 294, we'll say, feet. That's pretty good rounding right there. 294 feet. Easy as that. I'm going to take that work and I'm just going to shrink it down here for a second. Okay, let's go back to this problem and say, let's do this problem from the perspective of the boat. Okay, so I tell you that the angle of depression is 27 for the lighthouse keeper, but I want you to work from the boat person's perspective. Okay, so we need to find out what that angle is. Well, that's easy enough, a couple of different ways. First of all, I just showed you how to find that one to be 63. Of course, that's right. And I used the triangle sum theorem to find out what this angle is right here. Okay, so go ahead and put me on pause and see if you can figure out what that is. Okay, that's no coincidence, it's 27. So I want you from now on not worrying about triangle sum theorem. If that angle of depression is 27, his angle of elevation is 27. That makes total sense since we have two lines that are parallel cut by a transversal. Here's the 27 here, and here's this angle that we're talking about, okay? And so that should be 27 as well through the alternate interior angles theorem. Okay, very good. So now we have that as 27. Let's go ahead and see if you can write a trig function that relates this angle, these sides together, and then solve it. Go ahead and put me on pause, do the whole thing on your own, come back and check your work. All right, so I recognize that as a tangent function. I put my information in there. I cross multiply and I get to this point right here. And then I'm going to divide both sides by 20, a tangent of 27. That will cancel out the tangent of 27 on the left-hand side, leaving me the d. And then I end up with 150 divided by the tangent of 27. All right, let's check our calculator and see what we get. And hopefully you realize we should get the exact same amount, even though it looks different. So let's see, 150 divided by the tangent of 27. Hit enter, and sure enough, the distance of the boat is still 294 feet away. Okay, so it doesn't matter whose perspective we're working with. The angle of elevation, if given, belongs right there. And that's nice, that's already inside the triangle. If I'm given the angle of depression, I'm gonna have to do a little bit of work to get the angle inside the triangle to be able to work it. All right, let's continue. All right, let's take a look at this real world problem. Here's a sign in my neighborhood. Now, I happen to know from some previous experience that these signs are, hopefully I didn't say anything there I'm going to regret. I just noticed that my video was still going. But anyway, from previous experience of another job, I found out that these signs have a 3-foot side to them. Okay, so all sides are 3 feet. Okay. Now, what I want to do is actually find out how tall the sign is completely. Okay, what's the full height of the sign? So let's first of all know that I know my own height, right, is 5 feet 9 inches. Okay, 5 feet 9 inches. So what I need to do is find out how high or how tall the sign is, and then I'll just add that to the total height to get the height of the sign. So let's focus in on the sign and kind of some thoughts on that, okay? So the sign is a 3-sided triangle, and we know all 3 angles are the same. That angle is congruent to that angle, okay? That means each one of those is 60 degrees. And what I'm looking for is the height of that triangle, right? That particular height right there, which is a right angle. So what ends up being kind of curious is that I have this triangle on one side. This is a 60 degree. This is a right. And just by default, that has to be a 30-degree angle there. And so if I can find out what that piece is, I find out the height of that sign. All right, well, is this a trig problem? No, I see the 30 and 60 there, and so I'm going to go ahead and know that this is a special triangles problem. Let's bring in the fact that each side is 3 feet. So we'll put that side as 3 feet, okay? And I only really need that one height. I don't need to put the other sides. Remember, this side along this side is not 3 feet. It's only part of the triangle, okay? But I only need that one side. All right, so to do this problem, I need to bring in my special triangles. So I'm going to bring it in, draw it just like that one, put a 30 down here, and a 60. I know that my sides are 1, 2, square roots of 3, and I just need to put them in their correct places. 1 goes across from the 30, 2 on the hypotenuse, and square root of 3. Okay? So let's go ahead and start finding what x is. Okay, well, x is the square root of 3, right? As 2 is to 3. I'm going to cross multiply and I get 3x equals 2 square roots of 3. And then I'm going to divide both sides by 3 and I get 2 square roots of 3 all over 3. Since we're talking about an actual length, I'm going to go ahead and use my calculator and find out what that is as a decimal. All right, so I essentially have 2 times the square root of 3. Okay, I'm going to close my parentheses there. And then it's time to divide that by 3. I want to show you something. This is going to create an error in what the real answer is. Now, I'm going to actually use parentheses this time and go 2 square root of 3, close parentheses for the 3, close parentheses for the top part, divided by 3. And notice I got, oh, same answer. So it was actually very good at the way it did its math that time. So what we find out is that the height there is 1.15 feet. Okay, so now it's just a matter of taking my height and that 1.15 feet. I'm going to erase some stuff and give myself some work to work on. Okay, so I have 5 feet plus 9 inches, that's out of 12 inches, right? Plus that 1.15 feet. Okay, so this is how much 9 inches is out of feet. So now it's just a matter of putting that into my calculator. Okay, so let's correct that. That should be a little thing like that for 5 feet. Okay, so we'll add that up on a calculator. And so I get the total height of the foot, the sign is about 7 feet, 6.9 feet. Okay, a lot of work there, a lot of piecing pieces together. I think it might be worth just you backing up and watching that segment on this again. Okay? All right, well, this is an indication that it's time to draw your line, write your summary, and let's do some do it problems. So I'm going to scroll through this, and then you'll be on your way. Now what you'll see is none of these problems are from this unit 7.4. They're from this unit, but not from this section 7.4. And the reason is because these real world problems really change. And the only way you get good at them is experiencing them. And that's what you're going to do in class, next class. You're going to have to really do some thinking next class. Make sure you understand 7.1, 7.2, and 7.3 as you walk in, and you'll do just fine. Okay, today's homework is just basically review problems. Come in with 100% on those. All right, take care, you guys. See you next time.